Energy is conserved. That is, the amount of energy before will always equal the amount of energy after. Energy, however, comes in many different forms. There's potential energy, kinetic energy, radiant energy, heat energy, and so on. The many forms can complicate its accounting. You might initially fail to identify one of the forms and voila, you think you've discovered a perpetual motion machine. Such hopes have not withstood repeated experiments, which tell us that energy is always conserved through any process. It can change form, but what you start with is what you'll end up with. Let's look at a simple example to illustrate the point. A utility room with a heater pumps 500 kilojoules of heat into a living room. If the heater delivers 500 kilojoules of heat, the living room receives 500 kilojoules of heat, and no more or less than that. But suppose there's a toy car with a sail by the heating vent. The warm air flowing into the room pushes on the sail, which gets the car moving. A force is applied over a distance, which means work is being done on the car. Strictly speaking, the room won't be warmed by as much. Why? Because some of the 500 kilojoules of heat went to pushing the car. Let's make up some numbers here. Let's say 10 kilojoules of the energy went to pushing the toy car. That means the living room only received 490 kilojoules of heat, not the ideal 500 kilojoules. So heat added to the living room equals the heat received by the living room plus work done within the living room. Energy took different forms, yes, but remains conserved. Our accounting is good and none is missing. If we include heat and work in our discussions of energy conservation, then we're into an area of science known as thermodynamics. Thermo means heat. Dynamic means action. So with thermodynamics, we're talking about actions that involve the transfer of energy, heat. Our example of the toy car in the heated room focuses on what is known as the first law of thermodynamics, which is no more than energy conservation applied to thermal energy. When the accounting is proper, it all adds up. That's good energy.